Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about electric power reliability. We have special guest Alan Ross with us, and it is brought to you a part of Mobius Connect's ongoing YouTube series, Connect Conversations. I am Kim Fugger, and I am the manager of Mobius Connect, and will also be the moderator for today's session. First, I'd like to take a moment to introduce the hosts of Connect Conversations, series Global Reliability Improvement experts Doug Plucknett and Ron Moore. So before I pass the microphone over to them, I just want to encourage you here today, if you do have any questions or comments, this is going to be an open field. They will be able to open your questions live here, answer your questions here live, and just put them in the chat. We will communicate them both to Ron and Doug to answer. All right, guys, I'm going to pass everything over to you.
Okay, well, here we go. I'm going to say a few words, Doug, and I'll turn it back to you if you want. But our key speaker today is Alan Ross. So he's the guy that knows all there is to know about electric power reliability, or so we hope, So anyways, I met Alan on an airplane on the way home from a conference. We happened to sit beside one another, and we had just a great conversation. And come to find out, he is, I think, a founder, aren't you, Alan, of the Electric Power Reliability Alliance. And it's a networking group that brings folks together, and they share best practices and methods and techniques and all that sort of thing on electrical equipment. One of the things that he observed is that most of these conferences, people talk about mechanical stuff. Pumps and chillers and gearboxes and bearings and all that heavy stuff, and us mechanical engineers think that's great, because, that's what we're mostly interested in. But, if you can't get power to all that equipment, it doesn't do well, it doesn't work. So I think it's super that he's formed this group. I will make a couple of comments, and I'm mechanical. My dad was electrical, but I never understood it. If I can picture it, I can sort of get an idea of what it's doing. But electrical stuff, it's hard to picture, so hard to imagine. Anyways, but I would have this couple observations. One of them is that in terms of reliability, they follow the same principles that mechanical equipment does. If you design it right, if you buy the right gear, if you store it right, install it, operate it, maintain it right, it lasts longer and it's cheaper to, maintain. If you don't do that stuff right, well, it just doesn't do as well. And the second observation I give you is that electrical equipment, once you get it up and running, it just seems to run, for a long, long time. And so you don't worry about it until what? It goes poof, and then something bad happens, and then you worry about it. And so I think Alan and his group are trying to change that so that we apply the same principles to electrical equipment as we have been to mechanical equipment. And the second thing is that the time frames are different, the infant mortality period. My impression is, Alan, you can jump in there and correct me if I'm wrong. The infant mortality period is shorter for electrical equipment, particularly electronic stuff. If you flick it on and it goes poof, well, that's your, infant mortality period. It's all over. On the other hand, for transformers, it might be a year, because transformer ought to last 40 years. But they're all subject to the same principles and the same kinds of perturbations that induce defects and cause their failure. So I'll stop rattling on. And Doug, you want to say a few words before we turn it over to Alan and let him talk about what they're
in terms of infant? Sure. In terms of the infant mortality, especially the low voltage stuff, goes very, very quickly. Right. Just a part of a second. Yep. The higher the voltage, we tend to see longer. It's still infant mortality in most cases, but much longer PF curve, so to speak, in terms of should be able to detect it early on and plan and schedule and do things about it. It's not always true, right? We have things like lightning strikes that take things out, will take high voltage out pretty quickly.
That's what I call a perturbation, though.
Yeah, I'm really looking forward to this today because it's a great conversation to have for people, especially the folks like Ron and I that are mechanical people that really don't understand electric. And we hear people talk about, oh my goodness, our grid is in big trouble. We need to do something about it. And we've got this nice infrastructure bill. It's always nice to have somebody like Alan be able to talk to what does that mean when we say our grid is in trouble, right? My own thought of being a lay person and deathly afraid of electricity. I also come from a family that was mechanical. I have one younger brother that's an electrical engineer. We always thought he was a little strange anyway. As it turns out, now that we've gotten older, he's the only one that's not having any back problems. And we tease him, it's because of the little tools that electricians carry around. But at any rate, Alan, you're welcome to take this conversation in any direction you want.
Okay, let's do that. That's interesting. You both said several things that I want to focus on. First, let me separate the grid part of the system, because the people that make power so that we can use power have different problems, different situations they're dealing with, particularly now as we're going green, we're decarbonizing the grid. The grid is in trouble. There are really three grids in the United States: East, West, and ERCOT, which is the Texas grid. And I think it is but I'm going to use the word almost because someone will find a difference to this. Almost every industrialized country has a national grid policy, except the United States. We built it on these three, East-West. And by the way, they are allowed to talk to each other, and we're not. We can't share information. And it's just the way the whole thing was developed. And then throw on top of that 50 states, each having responsibility for certain parts of what those utilities go through. If I were in the utility industry, first of all, right now, I would be in a mental hospital blabbering, because I don't know how they do it, quite frankly. I don't know how they make major national decisions in a system of 50 independent state agencies, three separate grids, a Department of Energy, and other departments in government, including the Department of Defense, who all have their finger in the pie. And watch what's about to happen, because the feds have now said, we're going to spend, and it depends on who you talk to, 2.3 to 4.3 billion with a B dollars every year for infrastructure of the grid. Well, you know what can happen when money shows up, right? A lot of dumb ideas can come in because they get the ear of the king, and depending upon who's king. The good news is the Department of Energy is pushing that at a national level. And for the first time, we are looking at integration of those three separate grids. Texas was the last. I mean, Texas is the best at everything. And if you're from Texas, I'm going to say some things. Do not call me. Do not write me. It's an opinion. However, it's an opinion proven in fact. In the fact, when the weather got cold, your grid could not sustain itself, the Great Freeze. And when the weather gets hot, your grid has a hard time of maintaining itself. And so consequently, ERCOT itself is now saying, well, with all the kind of the weather events we've got, the way our grid is built, maybe we should be part of an integrated national whole. So when something happens in one part of the country, we can support it with power coming in from another part. Because the one thing we do better than anybody else in the world as Americans is we know how to transmit. We have these big transmission lines, right? We run them everywhere. We're the best at it. We know how to build them. We know how to maintain them. We know a lot about them. Unfortunately, we just don't have them cross each other. So if something goes wrong in California, I can't send power from the Midwest into the California grid because it's not part of the law. We'll get there. And there's a great deal of change coming in that. But that's not really where EPRA spends most of its time. We spend most of our time for the people that use power to make things. that use power to run motors, that use power to create vibration problems. All of the things that you two are the experts at, we're the cause of it, because without the power, you're not going to have vibration, or your pumps are not going to work, et cetera, et cetera. The hydraulics won't hydraul, and the whole 9 yards. You can get
we
that.
Won't make much product either.
You won't make any product. And it has been such an incredibly reliable system of assets: transformers, breakers, cable systems, switchgear. The system itself was built incredibly robustly, and that's great. In 1976, I think there was a transformer made by Westinghouse, arguably one of the best manufacturers ever. They're now part of the ABB, which is now part of the Hitachi Energy legacy. But Westinghouse made transformers that I honestly believe that 1976 transformer is probably now 40 some odd years old. I think it'll run for 75 years. It's that well built. But now they started to make them by slide rules, as opposed to, like, when I was at Georgia Tech, we made things by, slide rules. Now they make them by computers. We do not overbuild any asset. That's true, right? In the mechanical side for you guys, you can't afford, because the procurement guy will not pay you what it takes to overbuild an asset. And the company that's building the assets can't give you something for nothing. They cannot put more robustness in, more material, better material. They can't put in backup systems. They will put in what you pay for. And so consequently, the way we used to engineer these things was we engineered them. Engineers got with the people that they sent the bid out to and said, hey, here's what we want to do. Help us do it. We think it's a transformer. We think it should look like this, but you tell us if we know, because you guys are smarter than we are. You make transformers. And our engineers would talk to their engineers and they say, but did you know we came up with a new way of doing something? It's called a monitor. We can put on a hydrogen monitor. Hey, we can put this kind of bushing on because it's a rosin impregnated bushing instead of, and so as the industry got knowledge, we could share. And then in 1912, I picked that date for no other reason. A person was born. He was considered a purchasing agent. He was birthed to a woman in Idaho, and he came out saying, lower cost, cut your costs. These engineers are getting in the way. Everything costs more because of them. Make them give us the spec. We will then go out for bid, and we will make sure. So we stopped talking to each other. And where engineers used to, when the pendulum was here, I think it was too easy to be cozy. But we've swung the pendulum from engineering cost to all the way to the cost side. I think we're swinging it back and saying, are there better ways for us to put a tender out there to be able to do it? And that's, so that period of time where things became cost is gone from the Westinghouse years to the way it is today, where I do think we're doing a better job of speccing things. There is a period of time in there that the electrical equipment, particularly cables and transformers, are not going to be as robust as what we built in the 60s, 70s, and 80s.
You can
Go ahead.
add a layman's view of that. This is a conversation that I had with that brother of mine when we got talking down the hunting camp about the grid and the issues they're having with it. He's just a few years younger than me, and he says, I want you to think back when we were kids. How often did we lose power? Right? And he says, that's what we're talking about. And he says, we lose it so often now that every other house in the neighborhood has a backup generator.
Yeah.
Right?
And yeah, go ahead.
If those same people that bought backup generators put that money into the grid, we'd be all be a step ahead, right?
Absolutely. But here's it's an interesting thing. There's a gentleman, and you know him, Ron. Ben Lance is probably arguably the best cable guy in the world. You know, he is a cable expert. His company, ImCorp, they do a lot of cable testing, and they don't make cable, they don't install cable, but they can tell you where your cable's bad and how to fix it. And they've got some proprietary systems, but Ben is quite brilliant. He and I are presenting at the Electrical Insulation Conference for IEEE next June. And the paper that we wrote and the presentation that we made, at first, the geeks at the EIC didn't approve it. And they said, well, it's not technical enough. And our point was, we were pointing to something that's about to be a huge problem. We can only tell you this part of the technical. When you make as much power as we're making with wind and solar, particularly, gas generation also. But when you start making as much power with that, you create transients going back into the grid that are growing phenomenally. And as those systems also age, you will create more transients. As those transients enter that wonderful, robust industrial plant we talk about, you're going to have transients that will affect. So the power quality is going to affect that industrial facility that's using it to make steel. And the transient that didn't hurt 20 years ago is now going to cause problems again, because we have new equipment, new installations, cables deteriorate, transformers deteriorate. Why? Is because the transients have a greater impact on insulation, paper, and any kind of plastic insulation that you've got. So transformers and cables, we're already seeing it. So you've got this wonderful old system that's been able to withstand what's going on, but now we create a completely different grid. I have a wonderful slide that Dan Smith, the vice president of transmission and distribution for the Lower Colorado River Authority, gave me. And it's just brilliant, because it starts with slide one is the step down grid. Big power generation, coal, hydro, nuclear. You step it across the country, you step it down, you step it down, you step it down. The step down grid was easy. All of the transformers made in that system were made for step down. Now, somewhere in there, throw in a wind farm, throw in a solar farm, or hundreds of them. Throw in the guy that's got a Tesla Powerwall in the back, or a Generac generator. Throw in all of these things in there, and now it's a step everywhere grid. And the transformers that were made for step down Southern Cal Edison is finding this out, because there's so much wind and solar in Southern Cal that the transformers are aging twice as fast as they were, because now they are an inverter-based system. You have to step it down, unless, of course, the wind is blowing and the government says you got to buy that. You got to take that and step it up. So you're going step everywhere. And that creates enormous complexity in the system. It creates noise in the system. So you're getting spikes and sags that we didn't get before. And the utilities have got to try to figure out how to make all of that work together. The problem is it's going to be passed on. They will protect the residential customer at all costs, because that's what the government says. Microseconds or milliseconds of outages get reported. But you can shut down an industrial plant for 5 minutes, and that's not even an incident. If you're running a plant and your power's gone for 5 minutes, you better have the best backup system, especially if you're running any kind of a process thing, right? Try running chemicals or drugs or anything that you're doing in process management. Try running your robots when the power shuts off for 5 minutes. After 5 minutes, they have to report it. So consequently, the stresses that are on this new grid are really going to impact industrial, commercial, and other, if you will, more than anything. In 2001, EPRI, the Electric Power Research Institute, that is an organization paid for by the utilities to do research. They did a study in 2001, and they said the industries that are going to be most affected by power outages starting now, and they didn't even think about everything I just said, but starting in 2001, the most are going to be process industries, fabrication industries, and data center / commercial. That's our entire industrial network that we're trying to rebuild under these kinds of situations. So at EPRA, what we've tried to do is to say, how are you doing it? How is the practitioner out there who's responsible for keeping this electrical system going? What are the best practices to do it? We also believe that what other people call vendors, we call resource practitioners. And that's people that sell products into that marketplace, sell assets or sell services or sell testing. They see more in a day than most of the practitioners in a steel company see in a year. Well, what do they see that has to change? And that EPRA comes together. Ron is a keynote speaker at 3 events we're doing called Electric Power Reliability Experiences. We are actually using them as cohorts to do the first beta testing, peer review, of a new reliability and safety standard that we're creating that will then be put into a certification for a certified electric reliability professional. Ron, you were part of the one in California. You're doing one in Houston here coming up with me, and you and I'll see each other there. And then we're doing one up in Ohio. But as we got feedback from that first one, and we're not, that's the beginning of it. We're trying to take that data, peer review it, and then bring it in September to the Electric Power Reliability Summit. And we'll be doing a bigger one. And that's the final peer review before we actually publish it as a standard. And part of it takes into account power quality that has not been taken into account before. I've done a case study of a dairy company that Hussman, I think it's Houseman or Hussman, makes these incredible freezer units. They're the #1 in the world. And they took the company not to be named because I've named them before and was told by them, don't name us again. But they make a cheese type product that then gets flash frozen and frozen in these freezers, and then it's shipped out flash frozen all around the region. There's regional plants. So they decided that the freezers that they had to actually manually go and pull trays out, as the temperature changed, and they had multiple people monitoring these temperatures. They would have to go and pull out trays, and the tray on the bottom, of course, was colder than the one on the top, and you couldn't have that kind of variance. Well, they decided to replace them with solid state. They put in all these new solid state, multi-million-dollar solid state, one controller. And that controller, once the temperature at the bottom got colder than the temperature at the top, would blow air out of the fan system at the bottom up, or it could suck air from the top, or vice versa. But it could control the circulation in an almost exact way to keep that flash frozen product correct. One person operating it, as opposed to these people. No chance of a mistake where you kill 17 people in Tatumwa because you forgot to change the top of the cheese product that killed these people. Anyway, they did it. They were in install, so they did it during a shutdown. They were planning it. They hadn't gone through. There's no product in there. They're running the thing, and all of a sudden, randomly, these gigantic freezers started shutting down, just randomly. So they get all panicky and they bring in the suits and everybody. And over the course of about 3 days, they couldn't figure out what was wrong. Second shift electrician. He walks up to the guy from the company, the food company, and says, well, what's going on here? I mean, these people are not leaving. The lights are on. This is a big deal. And he said, it is. We can't keep these things running. We don't know why they're shutting down. We're blaming them. They're blaming us. We don't know what it is. We got software people in here. It was a mess. Almost millions of dollars of lawsuits. Second shift electrician says, well, did you know that feeder line from that transformer, which was a tertiary, it wasn't a primary sub outside. It wasn't even a secondary sub running that part. It was a third level sub, a pretty big transformer, an important one, a good one. They tested it. Everything was good about it. There's always been harmonics transient in the line from that feed. Always have been, never been a problem before. Maybe you ought to check it out. I love when Ron says this. Maybe you ought to check it out. It's like, you see a problem and he'll come up with a simple solution. Say, maybe you ought to check it out. So they went and checked it out. Sure enough, there was harmonics in it. And they put in a $1,500, $1,500, not millions of dollars, controller transformer, which is just nothing but takes out the noise. And guess what? Nothing shut down. That is happening all over America. Little transients that used to not bother the system are causing problems today because we're moving to a solid state mechanical as opposed to electromechanical, right? And solid state reacts differently to transients than electromechanical. They're very forgiving, but solid state is not very forgiving. Then you add the fact that there are going to be more transients coming in from the grid. And boy, I wish I were 30 years old. My career would be set for the rest of my life, but I'm retiring age. I'm too old. Ron wants me to write a book. I'm going to do it, Ron. I promise.
Okay, I'll help.
Yeah.
I've got one comment, or maybe
What's
a
that?
couple of comments about some of this. I was told, again, I'm not an electrical guy, but I was told that all these transients, because of poor power quality and sidebands and whatnot, the equipment doesn't know what to do with that. So, but it's energy, right? So it takes that energy that it would otherwise use to drive the system and converts it to heat.
Yeah.
Well, what kills electronics? What kills electrical equipment? Excess heat.
Yeah.
And so unless you get rid of those transients that generate excess heat, you're going to have a lot of failures. And I mean, to me, that's a pretty fundamental principle.
We're reliability people. That's what I love about both you and Doug. We're not maintenance. I mean, he's taught me this, that some of the organizations that have reliability and maintenance is like big R, little m, big R, reliability. And the idea that one of the great things is we're getting to redesign the grid because of the way the government is helping with that. And everything's up for it. So, and it will be redesigned correctly. I don't think the utility engineer that has reliability as a mantra 30 years before we thought of it in industrial America. The reliability of the electrical system has been tantamount. I mean, SCADA systems, reporting systems, all the things that they've got, they're just dealing with a lot of change, new entries into their system. But even that, they've learned how to live with the inverter based. What is happening now, though, the demands that are coming from, we're rebuilding industrial America. I mean, if anything, this COVID crisis and the supply chain crisis that we're dealing with is bringing back production to this country. Hopefully, when we build back, we will build it back correct. We will build a new plant the right way. But at the same time, a lot of old plants have to be repurposed. And you don't have to, as I said, the last thing you want to do is just say, hey, let's go out and let's go out and recable and put in new transformers and breaker systems everywhere. That's virtually impossible because most of the cabling is underground and most of the cabling is under the cement that is the floor that the machine rests upon, right? And so consequently, you're not going to go and tear that floor up and do it. And I didn't realize this, but I'm a transformer guy at heart, right? That's where my passion lies. The exact same problems that we have in a transformer, with a few exceptions, are the same problems that they have with cables, with a few exceptions. They have some problems we don't, we have some problems that they don't. When Ben and I did this paper, we realized we kept talking about the same thing with a different impact. And to Ron's point, the most important or negative impact is excess heat where you do not expect it. And you're already expected to run it hot. You know, if you're running a furnace transformer, you're going to run that 130% of rating already. That's just the nature of the beast. But to add that extra 3 or 4%, suddenly that's the difference between having your aluminum smelting line stop smelting and all of that aluminum in the line just hardens, or getting through it. So old assets are not necessarily bad assets. In fact, in many instances, they're the best assets, but even they will react differently to the power quality issues that we're going to be dealing with. Spikes, sags, transients, that's all going to be a part of the future that the electrical engineer at the site level. And you know what they do at data centers, right? They just duplicate everything or triplicate. They call 5.9 reliability. having 99.3% on this line with 99.2% with a generator backup and 96.4%. You add it all together and they'll say they got 5.9 reliability. Well, no, they don't. Because if they take out one of those systems, they don't have 5.9 reliability. And the way the world is going, there's a lot of pressure on data center managers to take out triple redundancy. And, you know, if you've read anything about generators, generators are notoriously, they uniquely fail for a very short period of time after startup, because they're not being tested. And they go and test the generators, right? But they run it for 5 minutes in a test. Try running that thing for 5 hours. Or as in New Orleans, every generator backup that they did in the last hurricane failed, every one of them that they put in because of the first failures of the entire network. And they failed because they had to run for days, not 5 minutes. Testing them for 5 minutes, it's like, you know, you can get me out of bed and you can get me talking for 5 minutes like I know what I'm doing. But if you get me out of bed and you start me talking, about 10 minutes into the time you start me talking, I'm start going, where's that coffee? I said all I need to say.
Okay.
Well, I got a comment too on that, but go ahead, Doug. And I've got a comment about diesel generators.
Okay. Ron and I have talked a lot about OEE as a measure, right? And it's one that when I teach the course, I say, gee, it works great for pretty much everything but utilities, right? Because utilities, your OEE should be 99.9 something.
Right.
But then as I sit back and listen to you, I say, well, there's a lot more to that than just having the power there, right? What's the quality of that power?
Yeah.
Right. And if we start looking at the quality of that, what does that do to that OEE number? Right. Is that something that you folks at EPR have looked at?
It's interesting that when you look at, you're right, OEE for a utility ought to be as close to 100% as you can get. Yeah. However, what's happening today is because the way the step everywhere grid, right, the inverter-based grid, you may have assets today that are necessarily not online because other assets are online taking care of them. For instance, for 6 minutes about 2 weeks ago, I think it was 2 weeks ago, maybe a month ago, in California, the entire California grid ran on green energy for 6 minutes. Wow. So what happened to all of the other equipment? I mean, it was running, but it wasn't producing. Was it an OEE? Was the OEE high? No, because it wasn't producing anything. And we're seeing more and more of that you've got to be able to produce when they want you to produce. Now, I think there's parts of the equipment that you would look like that you'd say, hey, you know, we can put some redundancy into it. And that's basically going to be backup storage systems and backup generation. So I do think you're going to see your OEE in fact, I would hope that we get a new measure, and that new measure is 90% OEE with 5.9 reliability. That would be a fascinating target.
Interesting stuff.
Yeah.
Go ahead, Ron. I have another one, but jump right in there.
Well, just a couple of comments now. These base load units are not designed to cycle.
No.
And we're starting to cycle them, and they don't like that. They it's like the step up transformer that was a step down transformer. Yep. They don't like that. So we better be really careful about how we do that and whether we do that, for that matter. So that's one.
You mentioned something earlier, Ron. You said design for reliability, and you know that's a passion for me too. Is when you're looking at any system, I don't care if it's electrical or otherwise, design it for reliability, and that goes to the very beginning of why are you having a system in the first place? Yeah. And given the changes that are taking place in the utility world, we need to go back and look at what are we designing it for? Yeah. And where utilities have typically designed for the residential market. And the industrial market is the bulk buyer, right? You buy bulk power. The minute you buy bulk power, assume it's just like when you buy bulk anything, there's probably some mice turds in it. Yeah. There's probably something in there you don't want. When you buy bulk power, there's probably some mouse turds in it, and you better clean it before you use it. And so the utilities get away and the rates are lower. And of course, public utility commissions go crazy. How come they get this low megawatt rate and the consumer does this? Well, the consumer buys 10 of them and they buy 10 million of them. And it just lets us gen to them. And we don't have to worry about anything other than getting that power to them. They have to worry about using the power. Well, I think today we should look at almost every distribution unit. Now, whether that's a city or whether that's a neighborhood or whether that's an industrial plant, as a standalone node on the system, and make sure everything within that unit is reliable. Force the cities to say, you've got to be part of reliability. I'm going to get if somebody that's out there listening, municipalities are the worst at it. They have, to me, the most under-maintained, overused, overextended, aging systems. And most cities are not doing a lot about it until they have a catastrophe. And oh, by the way, a lot of them are underground and all along the coast. You know what happens when you have underground units? Now they're built to withstand these things, right? However, the aging of that infrastructure and the lack of upgrading means we should look at cities like Birmingham, cities like Austin that are saying, hey, how do we come back and start over? We're not going to replace everything, but what do we want to accomplish? Because there's changing load patterns within a city. I mentioned about the Atlanta Braves moving to Marietta. That area probably uses twice as much power on the average evening, just lighting everything around there, right? Well, did they look at the needs of that part of the community? I'm sure they did, because we're near Georgia Tech. Georgia Tech doesn't like to do things that fail around them. We build good roads, and I went to Georgia Tech. Obviously, good engineering, you start with a design thing, but I think we need to think about that. Design, what are we trying to accomplish with the system? Look at the plant. You're making something and you're changing the way you make it. Robotics are changing manufacturing, right? What does every robot in the car industry have near it or at it, or maybe a collector? Maybe two of them have it. They have a transformer. They have a dry type transformer. What is that transformer doing? It's powering them, but it's also creating quality power. Affect that transformer with a transient coming in the line, you're going to affect that robot. And that one little becomes a leak in Mrs. Jones' car, and she keeps taking it back to the dealer, and suddenly they have a recall for bad welding or whatever the issue is. So the more we move to robotics, Amazon's going to move to all these robots pulling stuff off of the shelves, and they're going to have to be powered somewhere, and they're going to have to be recharged somewhere. I love the fact that these are the most exciting times. I did something at IEEE Power Energy Society T&D, the Transmission and Distribution Expo and Conference. We were able to do EPRA and APC Media and the Alliance. We were able to do 38 interviews with thought leaders, 38 video interviews that we're just now beginning to publish. They are IEEE interviews. They're also APC Media / EPRA interviews. So I asked people from Hitachi Energy or the presidents or the CEOs of companies, number one, what's happening? Everybody had, first of all, the same answer. If they were in manufacturing, it was supply chain issues and labor issues. And if they were any sort of a service, it was labor issues and it was other, but they had certain, but I said, beyond that, we're going to, supposedly, the grid has been level for about a dozen years. We have not had a demand increase in North America. Last year, we had the first increase in a while, which was interesting. It is predicted when we are a 30% EV production, not 30% actually being driven, but now the car companies are producing 30% of their vehicles as EVs, and every car company has that as a goal by the year 2033, I think it is. But let's just say the next decade, they are predicting a doubling in the demand of power. Not only do you have all of these negative issues we're talking about, but now you're asking for a doubling in the demand for power. And you're not going to be able to get there just by the consumer conserving. So we really need to start thinking as a country, what does that mean? Henry Ford got together with a guy named Rockefeller, And he said, I'm going to start making these cars just like they're coming out one a minute. I'm going to pop them out, and the guy making the car can buy the cars. Get ready for it. And he said, what are you telling me that for? And he said, because you know what they need to run? They need gasoline. I need you to start refining gasoline all around the country, and they need a place to go and get it. Well, we're trying to do that with EV charging stations, but remember, every EV charging stations has to be supported by the grid nearest it. You can't just put them in. Tesla can do it all by himself because he's a little bit of what we're going to be when we're a nationwide charging thing. But when it starts to get to the point that there's a new charging station that went in near a friend of mine's house in California, and they had to put in a new substation to support the charging stations that happen in there. Wow. Now that's thinking, that's planning. The new substation, Southern Cal Edison, said, you're about to take on a lot more power. Now you've got something, because if they'd have just built these charging stations and sucked off of the old grid, everybody would have had brownouts. Everybody would have had, and here's what they'd say, well, there's not a lot we could do. You can think, for goodness sakes. Think about, I have a new mantra. What is it? What is the end in mind? And I know Stephen Covey supposedly invented it. He didn't. A guy named Charles Handy in the 1920s discovered. He was an engineer, mechanical, and he discovered, along with the Handy curve, he discovered the fact that if you start with the end in mind, especially in a production system, right? What are you trying to do? What's the outcome? Well, the outcome is we want to take 30% of the vehicles and charge them off the road. What do you need to do to have it? You better have a good supply of power. So you put all that pressure back on Southern Cal Edison, who's got pressure from the California government saying, oh, by the way, you got to be 40%, renewables. And nobody wants a wind farm in their backyard, and nobody wants solar farms in their backyards. So you got to put them in the desert.
Nobody wants to authorize more capital and increase rates to pay for it.
That's true. That's it too. That's it too. But you remember Walter Cronkite was a real big advocate for this whole green energy thing long before any of the other pundits were. So they were going along, and then they decided they wanted to put one on off the shore of Martha's Vineyard. Oh. Guess who lived on Martha's Vineyard and who said, not in my backyard?
Yeah.
Anyway.
I want to go back to that diesel generator thing.
Okay, go ahead
for a second. Diesel backup generators, right? Most critical facilities have them, and I don't know how often they do this, but notionally once a month they start them up, they run in 5 minutes, and they shut them down.
Right.
Once a month, right?
Yep.
And you do that 36 months in a row. Well, every time you do that, you're inducing, heat stress and cool stress. And every time you do that, you're inducing more problems with that machine. So it's no damn wonder after you've done that 50 times, you start the thing up and you expect it to run 3 days. Well, everything's busted. So it's either got to be designed to do that, like a motor you start and stop frequently, or you don't do it. Or if you do it, you have to run it for an hour and then let it cool down in a slow fashion. So, and if you don't do that, well, you're just asking for problems in the future if you need it for very long. So that's my nickel's worth.
Hey, Scott Thornton just gave us a question and a statement. Thank you, Scott, from Ohio. The issue with EV charging here it's Ontario. I grew up in Toronto. Was an issue discussed last week at the Power of Water conference. Serious consideration is underway due to a fear there will be shortages in the grid. Yes, that's true. One option is they will backfeed the grid from battery-driven cars that are connected to the grid for charging. That's true. Consider getting up in the morning and go to work in your EV car and find that the battery's been drained because the grid took it. The grid took it to you. You're exactly right. It's not a simple solution. And oh, by the way, all of those cars, when they show up, you know what we're all going to do when we turn on the air conditioning and walk into the house at 5 o'clock after work? We're going to suck electricity from that grid like no man's tomorrow. And we think we have a demand on the grid now in the afternoon, in the evening, early hours when everybody's back home running the dishwasher, running the washing machine, et cetera, et cetera. Add your EV charging to that, it's going to be a problem. So yeah, there's an interesting thing. I am a big component of people and companies, and one of my favorite companies is Velco. It's the Vermont Electric Company, and Vermont Electric Company. Their COO Chris Root is an IEEE fellow, brilliant man. He shared with us on a Zoom thing. Here's how they're handling it at Vermont, which, by the way, gets a lot of its power from wind and solar. I did not know that. They do half of New Hampshire, all of Vermont, and they get wind and solar. Who knew that they got wind and solar in Vermont? But they do. So they have a network of wind farms and solar farms, but they've got to figure out how they balance it. So they bought, at the time, I think it's double this now, but at the time they bought 2,000 Powerwalls, the Tesla or Generac Powerwall, which basically they put in their customers' homes. The customers decided, yeah, I want one. But the customer didn't run it. The customer didn't own it. It was controlled by Vermont. So as they were producing power that they didn't need, they would store it in all of these places. And as they needed power they didn't have, yes, they were still generating old-fashioned way, but now they were draining 2,000 that they were causing to be used wherever they needed. And then when they made the power again, so they have a storage technique using their customers' homes to do it. And there is some benefit to the customer in what they pay and if they have an EV. But that's a brilliant solution. There's a brilliant solution that we ought to think about, put the consumer and have us be part of the solution, not always the problem. And then have the utility say, look, because you are going to be my backup storage power, because we don't have a much better way today. You can put a battery farm in, and some of those are getting better and better and better. But the truth is we don't do good wholesale storage. So why not just do massive independent storage? Go to all of the industrial sites and say, if you guys could put in a bank of storage units, or they put them in like these containers now, and you store power when we want it, we'll make sure you don't ever lose power. That's a brilliant idea. It's $1 million idea. I'm going to put it in the book, Ron.
Interesting stuff. That was the question that I was going to.
Sorry, Doug.
Probably, I want to say it was 2 or 3 years ago. I worked with a company down in North Carolina that was attempting to build large storage units, the size of a tractor trailer back in. And they had promised, I think they wanted to do 2 a week. And when I got there, they had successfully made 1 in the past year. So they ended up going under. They had a Russian investor, and he finally said enough's enough. But that's an interesting concept, and I think that's really one of the things that would help our grid and these problems that we have with the uneven power throughout it, is to be able to take that power offline, store it, and then bring it back online evenly when it's required. Where are we as a nation doing that? It's interesting to hear that story from Vermont. That's a genius idea, actually.
That process of, unfortunately, it was left to the startup market to do that. And there was a company in Texas that created one, and it's one of the most famous ones. It was in Hawaii, and it was a lithium ion rack storage system, and it burned right to the ground. It created a huge mess and created lawsuits. The company, of course, went out of business. And so you've got some of those things, because when you think about that, that's a lot of storage of these little lithium ion packs.
Oh, right? Yeah.
But that's really about all we've got today to do it. And the lithium ion folks are doing a much better job, and they're learning a lot. There's a company that I just interviewed, and for the life of me, I can't remember the name, but they are probably the best at battery storage for EVs. And, if you've got a boat storage thing, or an EV, or an off-road vehicle, or Airstream trailer, those kinds of things, they're the best at it. So they have learned in that process, and now they're going scale on exactly what you're talking about, but they've already got the pedigree to be able to do it. It's not like somebody saying, hey, let's just put a bunch of batteries together, because it's the movement of electrons from that storage unit and into that storage unit
Mhm.
that is the problem. Because as Ron says, it creates heat.
Sure.
Heat can create problems. And the company that I'm thinking of was able to develop a way that it's not going to combust. It's called Dragonfly is the name of the company. It's not going to combust. And they're not new at it, right? They've been doing this. So if you went and bought one of those off-road vehicles that's electric, you're going to have their batteries in it. They're the best in the world at it. And now they're going scale for utilities. I love to hear it because I think those are the people. That's today the solution. There's a gentleman, Doug Hausman, who was one of the guys that created the standards from IEEE. He created the standards for the smart grid. Brilliant man. I work with him on the smart grid committee of IEEE. I interviewed him as one of the thought leaders. Doug thinks that we have, and when Doug says this, I believe him because he's got the technical know-how. Now, he said, we just don't have the political will to do it. That you could go off the coast of Texas near Houston and you could put an underground battery storage unit, a flow battery technology that wouldn't harm the lifeline, wouldn't have any negative effect on the environment. And basically you use the ocean to be able to store power. And then you could pull it utility scale when you need it into the Houston, to the Corpus Christi area to do that. He said, now we're 20 years away from that. I wish we were 10 years away from something in all the coasts that we were able to figure out how to use the ocean for battery storage. And if you want to find out about that, look up Doug Hausman on LinkedIn and say, hey, Doug, you had this idea. I want to fund it. And he'll go, the Doug's a brilliant man and does understand this industry probably better than anybody I know.
It's great stuff. So just as Ron and I expected, this hour flew by, and we could actually probably have you on several more times to get these conversations out, because really this is what people need to hear. There's so much false information that's out there about how we're going to deal with this, with the electric cars, with the wind turbines, with the solar energy, right? And it's fascinating to hear somebody that understands how all that stuff is supposed to work together. All right. It's also disappointing to sit back and say, gee, as a country, we don't know enough to really put together a team of people to work on this, right? Whereas it's funded by the government. We don't seem to trust our government anymore, right? Mm. To say, here's the correct components to do this. Here's the correct way to design this system so that we have something that's as good as we had in the 60s and 70s, right? Or right. Better would actually be the goal, right?
Yep.
Well, I'll offer a comment. Americans are great at managing crises.
Yeah.
And we're in one, Ron. We're in one and we don't know it. That's the problem.
Yeah.
Weather events and the demand on that we have always had there. The lights have always gone on, Doug, to your point. It's just been there. And as we start to lose it, we're not going to accept it. And we put pressure on the utilities to, hey, you're the ones that are supposed to do it. And let me tell you, I think overall, I'm talking about there's areas that, like I pick on munis, but overall, we have an amazing system in the United States, given what we have started, what we power. But, when you win wars, you don't rebuild, you rebuild them. And we've won a couple of wars and we've rebuilt other countries. We ought to start thinking about that for ourselves, and we ought to start thinking about working together to do it. There is one last thing, and this will be another one of those. There is a new modular nuclear facility capability that the French are using and that the Germans are using that I wish we would really look into. I know people go, oh, nuclear, just the word nuclear. Let me tell you, we have safe plants. They've been running a long time. California's Diablo plant, they're talking about shutting it down. Now they're talking about not shutting it down because they can't make enough wind and solar to replace that. But if we took this new modular site, you could put them all around the country and you could solve the problem, but you're going to have to look at it. And oh, by the way, they don't produce pollution. They are carbon free. And okay, this is a joke. So with all you nuclear, non-nuclear advocates, it's going to create limited amounts of spent nuclear fuel, right? That's the beauty of the modular system. It's not creating massive amounts. Stick it on one of the guy's rocket. What's his name? Tesla. Elon Musk. Stick it on one of his rockets and send it to the sun, and all it will do is add value to the sun. Because as it gets closer, it's going to blow up and it's going to go into the sun. It would just get a little bit more. The sun will live another billion years. But my point is, that's a problem that's created, but boy, does it create a huge solution for some of the things we're dealing with.
Well, just one more comment on that. A nuclear reactor that would power a substantial number of cities is about the size of a garbage can. All the rest of the stuff is, stuff that helps it run and generate the power and convert it to electricity and so on. But the reactor itself, is not very big.
Yeah.
So,
and the modular one is even smaller, even safer, and doesn't have that big footprint, Ron. Look that one up. Yeah. The Europeans are using it because they have to.
Yeah. So,
all right, gentlemen. We know Kim has to go pick up a cake. So
kid or a cake, Kim?
It's definitely a kid. Yes, definitely
a kid. A kid,
not a kid. I thought it was a cake. I was thinking dessert, Kim, for crying out loud. Like a kid, that's more important. So
I would never kick anyone off for a cake. Trust me. No, but Alan, thank you so much for coming on and talking about electric power. I know I learned a lot today and the feedback we're getting is great. So thank you so much for your time. Alan, if people do want to hear more about you or EPRA, where can they go?
They can't come to my house because I won't let them in, but they can go to alan.ross@myepra.com. myepra.com. alan.ross.
Thank you so much.
And the website is www.myepra.com.
All right. Well,
two of my heroes. Thank you guys, Ron, so much. I love what you do. You're a blessing to this industry. Doug, I'm sorry we made you a fellow and didn't tell you, but thank you for being a fellow because other people nominated you. What can I say?
He's a pretty good fellow,
All right.
Yes. Well, on behalf of our entire team here at Mobius Connect, thank you to our wonderful audience for joining us today, too. Just as a quick reminder, you can see past episodes of Connect Conversations on YouTube. We will share the link in a follow-up email to our YouTube channel, but be on the lookout. We do air these typically every other Tuesday at 2 p.m. Our next Connect Conversations will be the leadership models, so watch for that link to sign up. Thanks again for joining us. Have a great day. Stay safe, and we will see you all next time.